Thank you for joining us today just for my talk about chaos engineering in serverless applications. Today we are going to talk about how such kind of precautions you can take when you face with the chaos. So for example, my computer doesn't work for no reason with the stuff. This can be a chaos for a community conference. And I'd like to thank the organizers once again for organizing such a nice event. So, let me talk about myself very quickly. So, I was a developer for the first years of my career, and I then became a product person and working in Tundra, which is kind of a serverless observability tool which does chaos engineering and observability for serverless applications. And I'm also one of the organizing committee for Serverless Turkey meetup. We just had a serverless days in Istanbul just 3 days ago, and it was very fun, and we are planning to organize the next one next year. So let's talk about what we are going to do today. So by the way, I'm using a computer which I have no idea before. That's why there might be some problems with the presentation. I apologize in advance. So I will talk about first what's chaos engineering by definition, and what's chaos means on serverless applications, and what are the best practices, and then I will try to make a live demo if I can with this computer and see what we can do in terms of chaos. So you can start thinking of why we need to apply some chaos experiments on serverless or any kind of system. So you can say that, hey, my unit tests are working properly, my integration test doesn't reflect any kind of problems, and my UI UX test is very nice, and you might be very happy. But in these days, we are living in a kind of a distributed systems. So we are using different regions, we are using different availability zones in AWS, let's say, and everything fails. In such a system, as Werner Vogels, the AWS CTO says, in a distributed system, there's a tendency that everything will fail. It's not failed, it will fail. You will face a failure in any time. So you should ask yourself, you should come up with the questions what ifs to your system. You will say that, hey, let's say that I'm using a third-party API, from a very trusted vendor, let's say, let's not say, so from a vendor, and it slows down so badly, what will happen? And it's you should ask hey, it's I'm using that Fargate of this customers in US East 2, and sometimes there is a kind of a fail for a couple of seconds, but this can affect your system very badly. And just basically your cache and DB starts, it can go down for a reason, and you can just reach out to your data. So for such situations, you should actually plan some experiments, game days they are calling it as well, to experiment problems in order to creating the problems on your system in order to build confidence in your systems, and in order to claim that my system is turbulent to problematic issues. So this is kind of a Wikipedia presentation by Principle of Chaos. So what's chaos engineering is actually, so what you do in the game days, you just create the problems yourself. You inject some latency, you inject some errors, you intentionally, deliberately make some part of your system unreachable, and you see what happens in your system. So some big companies, I will come in a minute, that is doing this on production, but it may not be the best idea for the first times, and you can do it on staging as well. And it's you are injecting a vaccine to your system. So you are seeing that, hey, I'm injecting this little failure that I know about it, and see what will happen in my system. It's just after that, you will see how your system is reacting to that situation, and if this reaction is not the reaction that you are looking for, you have time to actually fix it. And that's why you have a resilient system. And it's not just it's just to prevent outages that can come out of these failures that you are not aware of. And actually, it's also because of it's also to define a steady state. So, for example, when you inject a latency to a third-party API, you see that some KPIs that you are chasing for is starting to slow as well, starting to be worse, but you will understand how worse can it be. So you will say that, hey, if it gets that worse, it's still no problem, and you will understand the steady state of your system. And like, sorry that like I couldn't update this, like it come to two of them together. So chaos engineering is not for breaking down your system. Like you are not just like making fun of like, hey, let's like take this DB down and like let's finish everything. And it's not just like making jokes to your colleagues. So like people do this, like, and just we need to be very careful about this. And it's not just for blaming to a person or to a group of people, like, hey, your system is not turbulent to chaos situations, and it's not like obvious for causing outages for your system. Actually, I really like this quote from Littlefinger from Game of Thrones. If you watched it, he was talking about the chaos in Game of Thrones, but it actually perfectly fits to the definition of chaos engineering. For you, like for your system, chaos isn't a pit. So it's kind of a ladder that will make you resilient due to turbulent conditions, that will make your system more healthy when it comes to have like bigger chaoses. So like let's talk about like how this thing came out. So it all started with Netflix back in like in these 10 years. So there was Chaos Monkey who was actually closing of some regions, and Netflix then make a simian army with this Chaos Gorilla, Chaos like all the family. And in 2014, there was the first job definition who is like on chaos engineering expert. And now in these days there are some tools like Gremlin, like Chaos Toolkit, Chaos Keep, like us, and which are doing chaos engineering on systems. So in my knowledge, these companies are using chaos engineering effectively in their systems. There was a conference like in the week before about chaos conference, and there was even like more companies were stepping up about it. And let's talk about like some informative definition of what's the states of chaos engineering. Like the first thing is that you will draw kind of a steady state of your system. And after that, you will make an hypothesis. Let's say that I will inject that much of latency to my system, and I believe that my system will not react with the X much of latency as a result. And then you will run your experiment, and you should actually define the blast radius. This is something very, very important. So you will say that, hey, I'm injecting this latency and this error to this particular, let's say, Redis cache, and you need to be sure that it won't propagate to some other parts of your system. And after that, you should also have a halting condition. Like all these actually rules are assuming that you will run it on production. But even if you are running it on staging, you should still have a halting condition and rollback plan. So let's say that you injected some failure yourself and it fails so badly. You should have a stop button somewhere, and you should have a plan to roll back the damage that you created for your system. And the last part is actually about learning. So after that you will verify that your system is great. It's carrying on in any case, or you will say that, hey, there's a problem that I should fix, and in this case that you will be ready for the problem that when it really happens. So like again, I will talk about this like more deliberately. You should not break the things on purpose. You should like start with the things that you also think that it can get problematic, like from this part of the layer. So so the problems that you are aware, and that problems that you can understand very easily. So you can say that, hey, I will start with such kind of issues. Oops. That's why I'm saying I'm using this computer for the first time. And actually the most important thing that I like to talk about here is that chaos days are should be planned in advance, like in a month advance, for example. And you should not all the company should know about that. There will be an experiment in these days. So let's say that like a very dummy chaos example, and still better than mine. So let's say that you are using DynamoDB for keeping the records, and let's say that let's inject some latency. So let's inject some error to Dynamo. So for like 1% of customers, Dynamo will throw a like not reachable error. So and you will say that like some people will experience timeouts while waiting for the results. So this is your hypothesis. You say that when I make the Dynamo unreachable for 1% of my customers for a while, I expect that people will be able to be able to see whatever they see because of my already prepared situations. But as a result, people started to experience timeouts while waiting for the results. So in this case, this is not the best thing that you can do. You should actually, as I said, a halting button somewhere. You should stop it and roll back what's happening here. So like, this is not actually something to teach. This is about like chaos engineering is not for running away. It's just like considering and accepting the consequences. So this is Adrian Hornsby. He's a technical evangelist of AWS, and I got this direct slide of him. And even if you fail as a result of the chaos engineering experiment, you will learn what's your time to detect an issue, what's your time for notification and escalation in and out of company, what's your time for public notification for a status page, and like, what's your time for healing happens. And what's your time to make everything stable back again. And let's continue. Let's come to serverless. So serverless is actually, again, a distributed system. And it's chaos engineering is more applicable and more required in serverless because everything starts to become more and more granular. So like when you start serverless as a first time, you will start with an API gateway and Lambda function talking with a Dynamo or like a Postgre. And then it will start to become like more event-driven architecture. So you will have some SQS bridges, SQS queues, which makes the connections between systems. And when you have a system like British Airways has, I suppose, you will have a Charizard, like systems talking with each other, like with many asynchronous events, many messages between lambdas and that are working asynchronously and very distributed system. So look at this map, that there are many places that you can inject latency, and which means that you can inject errors, and which means that you have now this granularity, and it means that like attack surfaces, the problem surfaces is now bigger. And like another problem is that every service has its own failure mode. So let's say that like retry. Let's talk about retries like for Nielsen. Let's say that you are retrying from errors from SQS. It's just retries 3 times, but for Kinesis it's like forever until the data expires. So there are different failure modes. So you should be careful about the failure modes of like every single resource that you are using. So there are different throttling, different retry mechanisms, and you should also pay attention about that. And like every function has its own configuration. Like I don't know how much of you is using different roles for different functions, but every function has different timeout parameters. Every function has different IAM roles for security, and that's why serverless is just full of chaos. So. But I'm not saying this just to make you afraid of serverless. I'm saying that you should be aware of that, and you should just build your systems. Even if you are not running serverless experiments, you should know that like that there might be some problems in your system. So like what might be the common problems in serverless? So basically you can have a function calling another function through API gateway or directly, and the inner function has a timeout bigger than the outer function. So like when an inner function runs normally I'm assuming that they are working synchronously. I'm assuming when inner function runs normally in the LO timeout period, the outer function times out. So in this case, you will have like a problem, like something very, very, very simple, but like something that you can face like very frequently in your architecture. Or like there's a problem with Dynamo, and this problem just propagates to your customers. So this may not be the best thing that you will want for that. I'm sure that you will have some handling mechanism for that, but still there might be problems about that. Again, Dynamo can create a problem. So how, like, what's the experiment in chaos, like for serverless? So like for example, Netflix with this chaos gorilla, they are just like taking down all the region, like, I mean, hypothetically. So what's the, what you can do in serverless to inject some chaos to plan a experiment day? So you can just inject latency to downstream services or to your lambdas directly, or inject failure to resources. So let's say that you are injecting latency to, I'm afraid of touching this, but you're injecting some latency to this lambda function, and you will see that you assume that the blast radius will be that with this lambda function as well. And in this case, and our hypothesis will be that enter point lambda, this one, will degrade gracefully when the downstream lambda times out or turns really late. So what's degrading gracefully? He will just, this lambda, I don't know why I called it as he. This lambda function will come up with already existing answers maybe, and will not wait for the answer. And as I say, like if you inject latency to async calls, you will just make it slower, but in this case, like, you won't make something that is not actually harming your system. This is not actually fitting with the idea of the chaos. So you can also inject latency to resources. So in this case, the blast radius becomes bigger, and you see what happens when Dynamo starts to return slow. So Yang Kui was actually living in this city and just went to Amsterdam, as far as I know, has some open source libraries to inject latency. And he's using the Promise architecture of Node.js, and you can reach out his works, and it's something very brilliant. And he's also injecting latency. I barely see the screen here. He's also injecting latency to resources, again using the promises and with async. So this is how it is done with Tundra, but I will show you in a minute. That's why let's skip this one. And you should also inject some error yourself. So you can say that let's say that I'm using a Dynamo or S3, and let's say that there might be a connection error. Let's say that my Redis cache is down. Let's say that like some AWS resource is unreachable. You can inject such kind of errors. And let's go with the demo with somebody else's computer. Okay, so this is like a Python function written for Lambda. So it basically goes. Can you see it? By the way, let me. It just basically I think yes. It just basically asks to cache for a user, and after that, if it's not found in cache, it's retrieving it from Dynamo and writing to cache again. So it's just like user get function. So as you may guess, this function works properly when everything goes all right. So this will be a very, very, very basic chaos experiment that I would like to show you in such a limited time. So you will say that what will happen when the Redis connection is not stable and is not working. So in order to do this, we will, let's say that we will run one time for this function and see how, is it working? Yeah, so it ran actually, and so this is how live demo goes. Are you happy now, Bruno? Bruno was calling me coward when I was doing it from a video.
What you did?
So I just.
I thought you just walked in. landed a question. I have no idea.
The internet is so slow, that's why I'm having problems, but now it came.
Can you help, Tony?
So, whoa, maybe I should connect to my HubSpot. Where's my, yeah, finally. So we see that this function is working properly when there is no problem. Redis is taking that much, then Dynamo, then Redis. Everything works as expected. So let's inject some already prepared chaos to that thing. So this is how we do it with Chandra. Oh, I can't even copy and paste from the computer. So what we do here is that I'm telling to Chandra that, hey, filter the classes, filter the things that's coming from Redis, and inject a connection error to it, and inject it at the end of the point. So, and I'm now creating it with this, and I filtered only Redis stuff, and I'm injecting a connection error to it. And I'm just registering to our trace support. So after I do this, let's say, it will take a while, I suppose. In the meantime, maybe I can also look at for other. Where's my phone, actually? Okay. Ben? Yeah, is it? Hey, come on. So I suppose I won't be able to do this because of the stuff. But the idea is that you will inject some problems to Redis, and it should not work like this. Yeah, finally. I don't know why. So when we inject a problem to Redis, let's wait for it appears in Chandra. We see that there's a problem with Redis, and all the rest of the function is not actually performing. So there's a problem with Redis and Dynamo connection, like your function is not performing perfectly. So like this can be like a very little chaos experiment. So what you need to do after that point is actually putting try catch to your function, and just making like taking this part to try catch, and it will be just working. Like if there's no connection to Redis, you will just like continue with the Dynamo. This is like a very small experiment that I was trying to run, but like thank you for bearing with me. And let's turn to presentation. I suppose we were coming to no. Yeah. So what might be the common fixes for chaos experiments? So you should let's say that you are having some latency. You should have some exponential backoff mechanisms just to try again, like maybe sometime later. And you should like be very careful. Like this is the most silly but the most common mistake. You should be very careful about tuning your timeouts. And if some part of your system becomes unreachable, you should implement some circuit breakers. Let's say that you cannot reach to Dynamo, and you should have like, hey, let's have another deployment of this function who is taking the data not from Dynamo directly, but taking somewhere from let's say S3 and showing some default data. And use of async communication is actually recommended, because in this case the failures because of latencies will not be there, but like the chaos because of errors will always be there. And I like to remind once again that like it's not, our aim is not to break, but to improve our system. And our aim is not to blame people, but just give a room time to improve themselves, and not to surprise your colleagues, but to make your system and your engineering more resilient. Thank you for bearing with me today. I'm